Hi students. In the last session, we discussed the order of a chemical reaction. Now, how will you calculate the order of a reaction? We have studied the rate law equation or the rate law expression. And what is the rate law expression? Rate law expression is nothing but the rate law is equal to a constant K into concentration of A raised to X into concentration of B raised to Y. So, this is the rate law expression. Okay. Here, K is the rate constant and A is the concentration of A. X is the power, isn't it? Power with respect to A and B. Y is the power with respect to B. Now, what are X and Y? X and Y are the order of the reaction. Now, what is the overall order of the reaction? We call it as N, that is equal to, N is equal to X plus Y, isn't it? And we also said the X and Y may or may not be the stoichiometric coefficient, isn't it? Okay, now, as the rate law can be determined experimentally, the order is also determined experimentally. That means order is an experimental quantity. Like the rate law equation, which states that it can be only seen through the experiment. The order can be also an experimental quantity. It is not a theoretical quantity. Okay. So, order of a reaction is an experimental quantity, isn't it? Okay. Now, from the rate law expression, that is, rate is equal to K into concentration of A raised to X into concentration of B raised to Y. This is the rate law expression. Okay. Now, how you calculate the rate constant K, or how will you define a rate constant K? How will you define? You can define the rate constant as if the concentration of this A and concentration of B are unity. That means if the concentration is unity, then you can say a rate is equal to rate constant, isn't it? If A and B, the concentration of A and the concentration of B is equal to unity, then you can say the rate is equal to rate constant. Clear? So, then we will see what is the unit of rate constant. It's very, very important. In board exam, 1 mark question will ask what is the order of a zero order reaction, or what is the unit of a first order reaction or a second order reaction, etc. Okay. Now, we will see how to calculate the unit of the rate constant K. Okay. Now, from this equation, we can write K is equal to a rate divided by concentration of A raised to X into concentration of B raised to Y. Isn't it? That is, K is equal to rate by concentration of A raised to X into concentration of B raised to Y. Now, what is the unit of rate of a reaction? You know, in the first session, we studied the unit of the rate of a reaction is mole per liter per second, isn't it? That is concentration divided by time, that is dR by dt. That is concentration of the reactant by time or the concentration of product with respect to time. So, it will be mole per liter per second, isn't it? So, if I write like that, that is concentration per second, isn't it? Concentration per second divided by what is again this concentration, that is mole per liter, isn't it? So, I can write this also I can write mole per liter per second. Okay. Now, here also I can write mole per liter. Okay. Here I can write like this, mole per liter per second. Then concentration of A is mole per liter and concentration of B is again mole per liter, that is X and Y. See? Is it clear? The rate mole per liter per second the concentration of A is mole per liter raised to X. The concentration of B raised to Y is mole per liter raised to Y. Correct? Now what we will do? We will say, you know, Ax into Y, that is X plus Y, isn't it? So I can write what? I can write here, I can write X plus Y, isn't it? X plus Y. And what is X plus Y, by the way? Is equal to N, the overall order of the reaction. What is overall order of the reaction? The sum of the power of the concentration of the reactants in a rate law is called as the overall order of the reaction, which is represented by N, isn't it? So I can write X plus Y. What? X plus Y as N. See? X plus Y as N. Correct? Okay. Now what we will do? We will do this. Here it is 1 and here it is N. So I will write it as, see, mole per liter. Listen, this is 1 by N. So I can write 1 minus N into second inverse. See, this is important. So the unit of K is equal to, I can write mole per liter raised to 1 minus N. Here it is 1 and here it is N. So if it is comes here, it is 1 minus N and second raised to minus 1. Now from this general equation, I can write what? I can now see what are the units of a 0 order, first order as well as second order. Correct? Okay, so I will write here K is equal to mole per liter raised to 1 minus N, second raised to minus 1. Correct? Now we will see what is the unit of this rate constant for a first 0 order reaction. Actually, for your 12th standard, you are only concentrating on 0 order as well as first order. Sometimes the question may be asked for a unit of rate constant for a second order also. So we will study only the 3, that is 0 order, first order as well as the second order. Okay. Now for this 0 order, so order is equal to 0. So n is equal to what? N is equal to 0. Correct? Putting n the value of n, that is order is 0. What is overall order? N. So you put n is equal to 0, then the unit is what? Unit is, see, K is equal to mole per liter. Listen. Mole per liter raised to 1 minus 0 is 1 and second inverse. See, it is mole per liter second inverse. Or I can write it as what? Mole per liter, that is liter second inverse. See, like this also I can write mole liter inverse second inverse. Clear? Okay. It's very easy. Just you put n as 0, 1 and 2 for 0th order, first order as well as the second order. Now putting the order as 1. What is the unit of K if the order is the first order reaction? See, 1 means 1 minus 1 is 0, isn't it? So I can write what? Mole per liter raised to 0 and second inverse. What is mole per liter raised to 0? 1. So the unit of first order reaction is second inverse. Very, very important. Board exam, they have asked what is the order of a first order reaction. Or by seeing the unit itself, you can say what is the order of the reaction. If for a numerical, for example, in a numerical, you are given as the rate constant unit is 1.6 10 to the power 9 second inverse. Then what is the information you are getting from that? That is, it is nothing but a first order reaction. So by seeing the by seeing the unit of a rate constant, you can determine the order of a reaction. Isn't it? Now coming to the second order. What is, if it is second order, what you will have? That is 1 minus 2. So what will happen? That is mole per liter raised to 1 minus 2 is what? This is second inverse. 1 minus 2 is minus 1 and second inverse. See, just put it in this equation. Don't want to by heart and all. Just if you have that rate law equation in your mind, you can know how to calculate it. That's all. It's very simple. So mole per liter raised to -1 second inverse. That you can write it as mole per liter. Liter when it comes up, it will be liter second inverse. See? So this is the unit of rate constant for a 0 order, first order as well as a second order. So you make a table and write this in your notebook. Okay. So by knowing the unit, you will know what is the order of a reaction. Correct? Now more about the order of a reaction, or talking more about an order of a reaction, we can say we know a balanced chemical equation, isn't it? Now by seeing a balanced chemical equation, you cannot predict the order of a reaction, isn't it? For example, if I say last class also we told about 2A plus B, 2A plus B giving products. Now if I say a chemical equation like this, I can't say the order of a reaction. It is determined experimentally. The order is determined experimentally. Okay. Now if I say reaction, a reaction can be of two types. That is a simple reaction and a complex reaction. In the first session, we talked about the mechanism. While studying the chemical kinetics, we will deal with three things. One is what is rate of reaction, second is the factors, and third is the mechanism. So in complex reactions, the mechanism comes in. Okay. So while considering a chemical equation, we can say that there are two types. That is, one is a simple reaction and second is a complex reaction. Now what is a simple reaction? A simple reaction is a reaction which takes place in a single step. Listen, a reaction which is happening in a single step is called as an elementary reaction. This is important. So what is an elementary reaction? An elementary reaction is a reaction which takes place in a single step. That's a valid point. Single step. So an elementary reaction is a reaction which takes place in a single step. Now what is a complex reaction? A complex reaction is nothing but reactions happening in more than one steps. A complex reaction means a reaction which is having maybe more than one step, maybe 2 or 3 or 4. We will deal with later. What is a complex reaction? Okay. So complex reaction means more than one step. And what is an elementary reaction or a simple reaction? A reaction which takes place in a single step. Clear? So that is all about discussing the order of a reaction. Okay. Now we will see about what is the molecularity of a reaction. Okay, that is also important. What is a molecularity of a reaction? Okay, so is it clear the order? Simple. Okay, so what is the molecularity of a reaction? That is molecularity. So what do you mean by molecularity of a reaction? In a simple way, I can say how many number of molecules are taking part in a chemical reaction. That is simply the sense of molecularity, isn't it? But when you consider chemical kinetics, we will say molecularity means it is the number of reacting species. You know, because it has to get reacted, right? Then only it will form products. So the number of reacting species, and the reacting species can be what? It can be atoms, or it can be ions, or it can be even molecules. So the number of reacting molecules that takes part in an elementary reaction, that is very important. Why you said elementary reaction? Elementary reactions are those reactions which are carried out in a single step. So in a single step reaction, how many number of molecules are taking part in order to form a chemical reaction by the exact collision between the molecules. You know, simply the reactants are not converting into products. there are many steps in which a reactant gets exactly into a product. Not that if you take two reactants and mix the reactants, it won't get product. And after all, no reaction is 100% getting into product. There's another way. So, in this case, the molecularity can be defined as the number of reacting species, that can be an atom or an ion or a molecule, in a elementary reaction. That is a value point. In an elementary, that means it takes place in a single step. Okay, which collides each other. Collision has to take place. Then only what happens? See, what is actually how we will say the reactants are converted to product. You know, in the case of reactant, a simple example I will say, N2 plus H2 giving NH3. A simple reaction if you consider. How this happens? First, this N triple bond N, isn't it? The N triple bond N, then here X single bond H, and here NH3. So what first happens? The reactant has to get broken down into this atoms, isn't it? So breaking up of the old bonds and making up of the new bonds is what is called as simply a reaction. So if that reaction has to happen, it must be having collisions between the reactants. And moreover, we will study in the later chapters that the collision must be proper collision, or the orientation of the collision must be in a proper, or only a proper orientations the reactants can be converted into product. Okay, that we will see later. Okay, so what is molecularity? Molecularity means the number of reacting species in an elementary reaction or an elementary step which collides each other in a chemical reaction. Okay, now if I say an example about the molecularity, it is just simply if I say simple words, I can say molecularity is the number of molecules which takes part in an elementary reaction or in a single step reaction. That's all. Okay, example, NH4NO2. See, the decomposition of NH4NO2 into N2 plus H2O. 4, so 2. See, if you take this example, that is NH4NO2 giving N2 plus 2H2, how many? This is an elementary reaction. You agree with me? Because it is a single step reaction. A single step reaction. Okay. Now, how many molecules are taking part in this reaction? That is only one molecule, isn't it? So, since one molecule is taking part in this reaction, the molecularity of the reaction you can call it to be a unimolecular reaction. So, this is an example of a unimolecular reaction. You got it? What is unimolecular? Because one molecule is taking part. But what is the point? It must be a elementary reaction or a single step reaction. That is the point. So, in a single step reaction, how many molecules are taking part? That is called as the molecularity. Okay, when definition comes, you have to say it should be colliding with each other and all. Okay, now if it is a bimolecular, how many molecules? Exactly, 2 molecules, isn't it? So, for example, see 2HI giving H2 plus I2. See, here what is the molecularity of the reaction? 2. Why? Because 2 molecule of HI decomposes to form H2 plus I2. So, I can say in this reaction the molecularity is 2. Why? Since this also has got what? That it is a single step reaction or it is an elementary reaction. Isn't it? It's a single step reaction. So, how many molecules are taking part in a single step reaction or elementary reaction? That is its molecularity. Okay. Now coming to, so this is called as a bimolecular reaction. What is it? This is called as a bimolecular reaction. Clear? Okay. Now coming to 3 molecules. For 3 molecules, what you will call it as? For 3 molecules, you call it as a trimolecular reaction or termolecular reaction. Okay. For example, NO, that is 2NO plus O2 giving 2NO2. See the reaction? 2NO plus O2 giving 2NO2. What is the molecularity in this reaction? It is a trimolecular or a termolecular reaction. Why? Because it is an elementary reaction. It's a single step reaction. And in the single step, how many molecules are there? 2 plus 1. So it is called as a trimolecular or a termolecular reaction. Okay. Now, when we talk about a tetramolecular or a pentamolecular, normally the probability for such reactions to happen is very, very rare. That is, it doesn't mean that it doesn't happen. It happens, but very, very rarely. So we are not going into more details for the tetramolecular or pentamolecular or hexamolecular reactions. We will just see what is unimolecular, bimolecular as well as trimolecular reactions. Okay. So you got it? What is molecularity? Okay. Now we will see. Suppose you have a reaction like a complex reaction, say. A complex reaction, say. Listen, KClO3 plus, it is in a textbook, FeSO4 plus H2SO4. See, in this reaction, this is 6, this is 3. So if, say, a hypothetical situation I am saying, if the stoichiometry, the order of reaction, if you say, if it coincides with the stoichiometry, I am only having a hypothetical situation, it can be said X and Y may or may not be stoichiometry. For example, in this case, if you say it has the stoichiometry, then we will say it is a 10th order reaction. See, 6 plus 3, 9 plus 1, 10. But actually, this is a second order reaction by experiment. What is it? This is a second order reaction by experiment. So when experimentally it is proven that this reaction, which is a complex reaction, the product is, if I write the product, KCl plus Fe2SO4 thrice plus H2O. Just refer to the textbook. Okay. So in this complex reaction, if you say, by according to stoichiometry, I can say if it is a 10th order reaction. But experimentally it is proven that this is a second order reaction, which means that just by seeing a chemical reaction, you cannot say whether it is a simple reaction or a complex reaction. So this is an example of a complex reaction. Now, as you know, a complex reaction, what happens? It takes place in so many steps, isn't it? Now, imagine for a 5 steps. 1, 2, 3, 4 and 5. Then the problem is how you will calculate the rate of a reaction for a complex step. You know, in a single step or an elementary step or an elementary reaction, you can calculate the rate of a reaction because it is only one step. Okay, and then in a one step you can calculate the order of reaction, that I will say later. Now in a complex reaction where you can have more than one step, that means for example say if there is a 5-step reaction, how you calculate the rate of a reaction or how you calculate the order of a reaction. That is, mainly in a complex reaction where more than one step reaction happens, the rate of reaction is determined by the slowest step. Got it? That means, for example, say, this is okay, right? For example, say, there are, in a complex reaction, there are 3 steps. For example, A giving B, okay, or A plus C giving D. The second step is C giving D. Then the third step is A giving B, like that. This is only hypothetical, just for information, that's all. Just for have a feel of it. Okay. So what happens is, if I say in these 3 steps, out of the 3 steps, one step is the slowest step. That means if I say this step is the slowest step, okay, that step is the rate determining step, or in this step is very, very important, and this step will determine the rate of a reaction and also the order of a reaction. I will say a simple analogy for that. In the case of relay, you know what is a relay race? Okay, 4 persons. Okay, now they are running and then one will have hand over the This, for example, like this, it will give to the other, and then the fourth one, the finishing point will be there. Now in a relay race, who will determine that winning position? Who will be there? That is, the runner which is a slow runner. The slow runner will determine the winning of a relay, isn't it? The winning will depend upon the slow runner. Likewise, in a chemical reaction, if it is a complex reaction, the rate determining step will be the slowest step. Okay, that means I will give an example for that. Okay, in an example, that is the decomposition of a hydrogen peroxide. Listen very carefully. The hydrogen peroxide decomposition, that is 2H2O2, is taking place in a catalyst, that is iodide ion. In an alkaline medium, you will get 2H2 plus O2. See? That is, in the decomposition of hydrogen peroxide, I minus or iodide ion is a catalyst, and this reaction takes place in an alkaline medium. Okay. Now, when the rate of a reaction is determined experimentally, listen, the rate comes to be, rate is equal to a constant K into the concentration of H2O2 and the concentration of I minus. See, the experimentally you got this. The rate of reaction equals K into the rate constant into H2O2, that is hydrogen peroxide concentration to the power 1, and the concentration of I minus. Where this I minus comes, it is a catalyst. That means in some reactions, the concentration of catalyst is also comes into the rate of a reaction. We only talked about the concentration of reactants, isn't it? But the catalyst concentration also comes into picture in some reactions. Right? Okay. So this is the rate constant, which means that what does this mean? This is a complex reaction. This is a complex reaction, and here it is the power of 1, and here also the concentration of I minus raised to 1. Okay, so order of reaction is 2, that we will see later. Now, if you say this is a complex reaction, actually this reaction is taking place in 2 steps. Okay, if you write this equation as rate law, actually speaking, this reaction is taking place in 2 steps. We will see what is these 2 steps. Okay, what are the 2 steps? First, what happens is H2O2 plus, in alkaline medium, it reacts with the I minus ions. Okay, in the first step, it's a 2-step process. The first step is H2O2 plus I minus will give you H2O plus OI minus, or you can say IO minus. Okay, so IO minus. Correct? Okay. Now, in the second step, H2O2 plus, second step H2O2 plus this IO minus will give you H2O plus I minus plus O2. See? Have you got this? This is a complex reaction which takes part in 2 steps. The first step is H2O2 plus I minus. Where this I minus comes from? That's a catalyst. So I minus will give you H2O plus IO minus. IO minus is an intermediate. Okay. Second step, again it reacts with the intermediate to form what? H2O plus I minus plus O2. See, you have experimentally proven that R is equal to K into concentration of H2O2 and a concentration of I minus. So from these two, this is the second step. From these 2 steps, which is the rate determining step or the slowest step? Say, which is the slowest step? This will be the slowest step. Why? Why? Because in this rate law expression, it is given as H2O2 concentration into I minus concentration, isn't it? So, the first step is the slowest step. Or while writing a complex reaction, you will specify here it as the slow step or slow. Which means that is the rate determining step or that reaction, this reaction, you will get it in the rate law expression. Understood? Not this. Why? Experimentally you are getting this. So in order to get this, which will be the slowest step? This will be, because this is H2O2 and I minus. So the formation of an intermediate is the rate determining step. And the power is what? The concentration of H2O2 raised to 1 and concentration of I minus raised to 1. Now I will say one thing. In an elementary reaction, listen carefully, in an elementary reaction, the power will be equal to the stoichiometric coefficient. Got it? In an elementary, first session we said what? It may or may not be the stoichiometric coefficient. If it is maybe the stoichiometric coefficient, then we told it must be a coincidence, isn't it? Experimentally, you have got that. But while studying the mechanism, it is observed that in an elementary reaction, that is in a single step reaction, where we consider the molecularity, the rate of that reaction, the order of the reaction is the stoichiometry. See, here the stoichiometry is 1. See, here it is 1 and here it is 1. So, raised to 1, raised to 1. So, it is a 1 plus 1 second order reaction. Hope you understood. What is a complex reaction? If more than a reaction having more than one step. And in a complex reaction, how will you determine the order of a reaction? The order of a reaction is determined by the slowest step. The slowest step is the rate determining step. Or the rate of a reaction is determined by the order, the rate of a reaction is determined by the slowest step. Now, once you got the slowest step, you can very well write the order of a reaction. It will be the stoichiometric coefficient of the slowest step. Correct? So, it is first order with respect to hydrogen peroxide and first order with respect to I minus. I minus is a catalyst. I already told you, in some reactions, catalyst also comes into picture of the determining the rate of a reaction. Sometimes product also comes into picture. Sometimes reactants doesn't come into, one of the reactant or two of the reactant doesn't come into picture. That all we discussed in the first session. Okay. So here the catalyst comes into picture, thereby the rate is equal to K into H2O to the power of 1 and I minus to the power of the 1. Okay. So this is a second order reaction. So you got it, how you study with the complex reaction. So how will you determine the rate of a reaction for a complex reaction? Correct. Now what is elementary reaction? It is a single step reaction is called as an elementary reaction. Clear? Now we will see the comparison between the order and the molecularity. Always in board exams it will come. List 3 points to differentiate between order and the molecularity. Now we will see 2 or 3 differences between the order and the molecularity. Okay. So you know what is the first difference? What is the first difference in order? Order is order and molecularity. Okay. What is the difference? The first difference is order is an experimental quantity, isn't it? It is an experimental quantity. Whereas molecularity, you can say it is a theoretical quantity. The first difference is order is an experimental quantity, whereas molecularity is a theoretical quantity. Correct? Now, the second, you know what is it? Order can have the value of negative, positive, then integer 0 as well as what? Fraction. Isn't it? Correct? What about the molecularity? Molecularity only positive integers. Correct? Not even 0, because 0 means no molecules, no reaction happens. So it only have positive values, integers. Okay. Now, the third and the important point of this order is the order is applicable to both elementary as well as complex reactions. What is it? Order is applicable both to elementary as well as what? Complex reaction. Okay, so I can say order is applicable both to elementary means what? Single step, elementary and complex reaction. Whereas molecularity has got no meaning in complex reactions, isn't it? That is very important point. No meaning in complex reactions. This was asked in the last year's question, that is 1920. How will you say, or what is the meaning of molecularity in complex reactions? The answer is, there is no meaning in complex reactions about molecularity. But the order has got both. It is applicable both to elementary as well as the complex reactions. And the last is, in a complex reaction, the order is given by, that's all, order is given by the slowest step. In a complex reaction, the order is given by the slowest step. And in a molecularity, what happens? In a molecularity, I can say the molecularity of the slowest step is order. Am I right? Molecularity of the slowest step means rate determining step. So that is equal to the order because it's an elementary reaction. We told you slowest step. So these are, so here this is the board exam question. Okay. So these are about what? These are about the differentiate between order and molecularity. Okay, once again I will sum up. Order is an experimental quantity. It is only by experiment you can say, or you can define, you can say order of a reaction. You can determine the order. Whereas molecularity means it's a theoretical value. Second is you can have the values of positive, negative, zero or even fraction. Whereas molecularity, it's a positive integer. It should always be a positive integer. And third is what? The order is applicable both to elementary single step reaction as well as a complex reaction. Whereas molecularity has got no meaning in a complex reaction. This was asked last year's question. Okay. Now fourth and the last is order is given by the slowest step. You know, rate determining step is the slowest step. Elementary reaction, only one step. But in the case of molecularity itself, we say is what? The slowest step is the order of reaction. That's it. So this is all about order and molecularity. Molecularity means the mechanism you are coming across with the molecularity. That's it. Okay. So read the textbook thoroughly and go through it. Any doubt? Okay. So till then, keep studying. Thank you.